Module 5 Web3.js and app development. Today we'll talk about React, a powerful JavaScript library for building user interfaces. And we'll also learn how it can be used to develop decentralized applications. React's component based architecture and virtual DOM make it an ideal choice for creating interactive and responsive app. DOM stands for Document Object Model. The DOM is a programming interface for web documents. It basically represents the page so that programs can change the document structure, style, and content. Okay. So, what is React? React is a powerful JavaScript library created by Facebook for building fast and interactive user interfaces for web applications. It uses a component based architecture, which means that complex UIs are broken down into reusable, self contained components. Simplifies development and allows for efficient rendering, as React's virtual DOM tracks changes and only updates the necessary parts. With React, developers can create dynamic and responsive web applications with a focus on modularity and performance. So, why use React for dApps? So, there are four reasons we'll talk about it. It has multiple more reasons, obviously, but we'll talk about four major reasons, right, to give you a brief overview. First is modular approach. React's component-based architecture allows developers to break down complex app user interfaces into reusable, self-contained modules. This modular design simplifies development and maintenance, making it easier to scale and iterate on app features. Next, we'll talk about seamless state management that you can get. React's state management capabilities make it well suited for building apps, which require efficient handling of application state, such as blockchain data, user interactions, and also UI updates. React state management features help developers maintain a consistent and predictable application state. We'll talk about React's enhanced performance. React's virtual DOM efficiency tracks changes and only updates the necessary parts of the page, resulting in improved performance and more responsive user experience. This is particularly important for dApps, which often need to handle complex real-time data and interactions. Next is modern tooling. React integrates well with a wide range of modern development tools and libraries, such as Web3.js, Truffle, and Ganache, which are essential for building and deploying dApps. This extensive ecosystem of tools and libraries helps streamline the dApp development process. Next, we'll talk about setting up React, right? I gave you a brief introduction. Now you have to learn how to set this up. Create a new React application. You can use the popular Create React app tool. Provides a comfortable environment for learning React and building a new single page application, also called SPA for short, from scratch. So you first open your terminal or command prompt, right? And then you run the following command: npx create react app mydApp. Once the project is created, navigate to the project directory, cd mydApp. So let's talk about the project, right? So first is the public folder. The public backslash directory contains static files such as HTML, CSS, and media assets that will be served as is by the web server. This is where the main HTML file, usually index.html, is located, which serves as the entry point for the React source code. The src folder is where the majority of the application source code resides, including React components, styles, and other JavaScript modules. This is where developers will spend most of their time writing and organizing the application's functionality. Finally, dependency. The node modules directory is automatically generated and contains all the project's dependencies, including the React library and any other third-party packages required by the application. This folder is typically not committed to the project's version control system. So let's talk about creating your first component. So in React, components are the building blocks of user interface, right? So you're making a building, you need bricks to build your building, right? To make a wall, you need bricks first. Bricks are the building blocks. How we say cells are the building blocks of our body, of the human body. So similarly, like that in React, components are the building blocks. What components do, they encapsulate the structure, behavior, and styling of a specific part of the application. So I'll take you through an example which will demonstrate the creation of a basic functional component. So import React from React function hello world, return h1 hello world exclamation mark h1, and export default hello world. So this component is defined as a standard JavaScript function that returns JSX, which is the syntax used to describe the component's UI. In this case, the hello world function simply returns the text hello comma world with an exclamation mark enclosed in an HTML div element. To use this component in your React application, you would import it from the file where it's defined and then render it in your application's JSX. This modular approach allows you to create reusable pieces of UI that can be composed together to build complex user interfaces for your decentralized applications. And just to elaborate what JSX is, JSX stands for JavaScript XML. It's a syntax extension for JavaScript used with React to describe what the UI should look like. Right? With JSX, you can write HTML-like code within JavaScript, which makes it much easier to create and manage React components. So we'll talk about rendering a component. In React, the React DOM.render method is used to render a React component to the DOM. This method takes two arguments, the React component to be rendered and the DOM element where the component should be inserted. So the component to be rendered and the DOM element where the component should be rendered. Right, I told you what DOM is already, right? DOM stands for Document Object Model. For example, the following code renders the hello world component to the HTML element with the ID of root. Import React from React, import React DOM from React DOM, import hello world from hello world, React DOM.render hello world document dot get element by ID. The hello world component is imported and then passed to the React DOM.render method, which inserts the component into the DOM element with the ID of root. This is typically the entry point for a React application, where the main component is rendered and the rest of the application's components are composed within it. Let's talk about JSX syntax. So JSX is a syntax extension for JavaScript. I already told you what JSX is, right? JavaScript. So it's a syntax extension for JavaScript used with React to describe what the user interface should look like. It makes it easier to write and add HTML in React, allowing for a more intuitive and expressive UI development process. JSX code is compiled into standard JavaScript, which the browser can then understand and render. For example, the following JSX code, const element hello world, right, is transformed by the compiler into the following JavaScript const element react.create element and null hello world. So this essentially demonstrates how JSX provides a more readable and natural way to describe the structure of the UI compared to using lower level React create element calls directly. By using JSX, developers can focus more on the visual aspects of their application rather than the underlying implementation details. So next we'll talk about components and props. Right? So in React, components are the building blocks of user interface. I have already explained, right? They encapsulate the structure, behavior, and styling of a specific part of the application. Props are arguments passed into React components, allowing for dynamic and flexible components. So props are the arguments passed, right? So here's an example of passing props to a component function welcome props return hello props.name welcome name Alice. So in this example, the welcome component takes a props object as an argument, which contains the name property. The component then uses this name prop to dynamically render a greeting message. By passing different values for the name prop, you can reuse the same welcome component to display different greetings. So you're changing the parameter, right? You can put different values of the name prop but you can reuse the same welcome component to display different greetings. So they are very useful as you can see. So let's talk about state in React, right? The concept of state is a very crucial concept that allows components to manage and update their internal data. By using state, developers can create dynamic and interactive user interfaces that respond to user actions and changes in the application's data. This example below demonstrates how to use the useState hook to manage the state of a simple counter component. Import React, useState from React, function counter, const count set count equal to use state 0, return count, right? Button on click equal to set count, count plus 1 increment. So the counter component initializes a state variable called count with a value of 0 using the useState hook. The setCount function provided by useState is then used to update the count value when the increment button is clicked. This causes the component to re-render, displaying the updated count value to the user. So we'll talk about lifecycle methods next. So we have three methods that we are going to talk about. First is component did mount. This method is called immediately after a component is mounted, inserted into the tree of React components. It's a common place to perform any necessary setup, such as fetching data from an API or setting up event listeners. Next is component did update. This method is called immediately after updating. It's useful for performing side effects like updating the DOM, right? DOM stands for Document Object Model, right? I've already explained this. In response to proper state changes. Finally, component will unmount. So this method is called immediately before a component is unmounted and destroyed. It's a good place to perform any necessary cleanup like invalidating timers, canceling network requests, or also removing event listeners. Let's talk about handling events in React, right? So this is similar to handling events in plain HTML, but with a more declarative approach. That's the difference. It's a more declarative approach. In this example, I'll show you how to handle a button click event using a custom handle click function. Okay, and when the button is clicked, an alert with the message button clicked will be displayed. So function handle click alert button click, button on click handle click click me button. The handle click function is defined within the component and is passed as an event handler to the button's on click prop. This allows the component to respond to user interactions and update the UI accordingly. By using this event driven approach, React developers can create interactive and responsive user interfaces for their decentralized applications or DApps. Next, we'll talk about conditional rendering. Conditional rendering is a powerful feature in React that allows you to render different UI elements based on the state or props of your component. Particularly useful in creating dynamic and responsive user interfaces for decentralized applications, apps, where the display may need to change depending on the user's actions. Okay, so here's the function. Function greeting props. If props is logged in, return welcome back. Return please sign in. In the given example, the greeting component uses a simple if statement to render either a welcome back message or a please sign in message, depending on the value of the is logged in prop. This type of conditional rendering enables the component to adapt its behavior and appearance to the specific needs of the user or the application, resulting in a more intuitive and engaging user experience. Now let's talk about lists and keys. In React, rendering lists of elements is quite a common task. This is often done using the map function to iterate over an array and creating a new array of list items. Each list item must have a unique key prop, which helps React identify which items have changed, been added, or been removed. In the example provided, the numbers array is mapped to create a new array of list items, with each item's key prop set to the corresponding number. Const numbers 1, 2, 3, 4, 5, const list items number map number like equal to number to string number ul list items. Key prop should be a unique identifier for each list item, such as an ID or a combination of unique properties. This allows React to efficiently update and re-enter the list when changes occur, improving the overall performance of your React application. By using unique keys, React can track the state of individual list items and optimize the rendering process, making your decentralized application more responsive and user-friendly. Now let's talk about forms in React. React provides a powerful way to handle forms through the use of controlled components. In a controlled component, the form state is managed entirely within the React component, ensuring the data is controlled by React. This approach allows for seamless validation, error handling, and dynamic updates to the form state as the user interacts with it. So, Yeah, I'll have a code example here. The code will continue through 2 pages. I'll read the code out to you and then I'll explain what each function does, right? First, you have a name form function, right? Const name set name use state, const handle change equal to event, set name event dot target dot value. Next, you have const handle submit equal to event, alert a name was submitted plus name event dot prevent default. And the continuation of the code return form on submit handle submit label new input type equal to text value equal to name on change handle change label input type submit value equal to submit. So in the example provided, right, the name form component, right, which we just did right now, demonstrates a controlled component form. The name state variable is initialized with an empty string, and the handle change function updates the state whenever the user types into the input field. When the form is submitted, the handle submit function is called, which displays an alert with the current value of the name state variable. Okay. So now let's finally talk about Web3.js with React. Integrating Web3.js with React allows developers to interact with the Ethereum blockchain directly from the React components. This powerful combination enables the creation of decentralized applications with a responsive and interactive user interface. By leveraging the capabilities of both React and Web3.js, developers can build apps that are user friendly, efficient, and seamlessly integrated within the Ethereum network. Import React, use state, use effect from React, import Web3 from Web3, function Web3 component, const account set account equal to use state, use effect, const Web3 equal to new Web3 given provider, Web3.eth.request accounts, dot then accounts equal to set account, account 0, return diff connected account, export default Web3 component. So this example provided demonstrates how to use the use state and use effect hooks. You're using both use state and use effect to manage the state of a React component and fetch the user's connected Ethereum account. When the component mounts, it initializes a new Web3 instance using the Web3.given provider and then requests the user's Ethereum accounts. The selected account is then stored in the component state and is displayed to the user. So now let's talk about building a simple DApp UI, right? We have already learned how to use React. We know about Web3.js. So let's talk about this. First, you begin with setting up a React project. We begin by creating a new React project using a tool like Create React App. This sets up the necessary boilerplate and development environment to start building your DApp user interface. Then let's talk about integrating web3.js. Install web3.js library and integrate it into our React project. This allows us to interact with the Ethereum blockchain directly from our React components, enabling our DApp to read and write data to the network. Then we create components. We develop reusable React components for interacting with our dApp smart contracts. These components can handle tasks like connecting wallets, invoking contract functions, and displaying blockchain data in a user-friendly manner. Finally, we build the UI. Combine our React components to create an overall user interface for our dApp. This may include pages for connecting wallets, viewing account balances, sending transactions, and more. We should ensure that the UI is intuitive and responsive for our users. Finally, we will deploy the React app. Once you have built your React application for your decentralized application, time to deploy it so your users can access it. The process involves creating a production ready build of your app and serving it using a static server. So it has to be static. So we use the npm run build command to create a production ready build of our React application. This optimizes the code and assets for deployment. Then we use the serve-s build command to serve the build files locally. This sets up a static server that can host our app. With our app now deployed, you can share the URL with your users, allowing them to access and interact with your app from their web browsers. Let's discuss our conclusion. We did a recap of React basics, right? So we covered the fundamental concepts of React, including components, props, state, and lifecycle methods. These core principles form the foundation for building user interfaces that are modular, efficient, and easy to maintain. Next is the importance of React in app development. React's ability to create dynamic and responsive user interfaces makes it a natural choice for decentralized application development. By combining React with the power of Web3.js, Developers can build apps that seamlessly integrate within the Ethereum blockchain and provide users with a polished and engaging experience. Finally, further exploration. We have barely scratched the surface of what's possible with React and Web0.js. I encourage you to continue exploring these technologies, experiment with new ideas, and push the boundaries of what can be achieved in the world of decentralized applications. There are endless possibilities. Finally, just a few recommended resources for further reading, right? So, for React documentation, you can dive deeper into React's concepts, APIs, and best practices by exploring the comprehensive React documentation at reactjs.org. So, we can learn how to build complex user interfaces, manage state, and leverage React's powerful features. Web3.js documentation. Enhance your DApp development by studying the Web3.js documentation at web3.js, read-the-docs.io. Discover how to interact with the Ethereum blockchain, handle transactions, and integrate Web3.js seamlessly into your React-based app. Finally, Ethereum developer documentation. Broaden your understanding of the Ethereum ecosystem by consulting the developer documentation at ethereum.org/developers. Learn about smart contract development, the Ethereum virtual machine, and other essential Ethereum related topics to build and decentralized applications. That's all for today, and I'll see you in the next video. Thank you very much.